Hi everyone, in this video, we are going to do some very interesting explorations. So this would include about a package called Lubridate, which is for dealing with time and days. And the second package we are going to discuss is dplyr, which is for data manipulation. And then the third package is called tidyr, which is mostly about data tidying. And we are going to see what we are going to use in this very interesting example. So you may also find some people just use tidyverse. So tidyverse is actually a whole package including dplyr, tidyr, and many other packages. So to make it easier, you may just load the package tidyr, a collection of packages. So to start with, I want you to do install.packages tidyverse. And make sure you put the name in quotation marks so that it is installing for you using online resources. So make sure you run that install.packages. It will start downloading, installing, and then after that, you just run the library function so that this collection packages are installed. So from this list, you can see we have included dplyr, tidyr, lubridate. So all the important packages we are going to explore for this video is actually all loaded and ready to go. Okay, so the first one I'm going to do is to do some exploration on time, date, or week. So let's define a date string and let it to be 2024, February 29th. And then maybe we can do 9 o'clock, 10 minutes, and 59 seconds. So let's define a string like this. And you can print it out and take a look. So you can see this is a very standard time. What you can do with it, for example, if you have a data set with all different records of this time stamp, then you can extract the day from that date string, like the day would be which day we are talking about, or even the months, which would be the second month of the year. And then you can also extract year. So sometimes if you want to do a comparison on like other yearly differences of your data set, you may only extract the year data to have a comparison, or you may only extract the months. And there is another very useful function called week of the day. So it's W day. As you can see, the week starts at 7. So let's use weekday, WDAY, on string so that you can see that day is actually the 5th day of the week because the day starts on Sunday. So the 5th day of the week would be Thursday. And if you want to explore more about it, you can do question mark on weekday so that you can see an explanation of it. So you can see here, week starts, day on which week starts, day on which week starts following, like 1 means Monday and 7 means Sunday. What you can do is to add label equals true so that in the printout, you are seeing exactly which day it is instead of a number. So these are the operations you can do. Think about you have a date column in your data set. then you can use these functions to extract those information out. So you can also do our function and the date string so that you can get the hour information extracted. So those are the standard things, operations you can do if you have a nice data formatted record in your data set. Okay, so the next thing we are going to do is to use a data example which actually has the timestamps in it. So first of all, I want to import a data set from CSV, which is a text-based file. I will also include that file in my description box. Yeah, I can just find the data set in my downloads folder and I open that data set. So this is a preview and you can see the heading is yes. That means each line, each column, the first record is the title. So click import. So you can see this data set has a flight date, city name, destination name, and also departure delay and arrival delay. So this is a flight data in November 2022. The first thing we are going to do is to, I think it's always a good idea to take a look at the data set, right? So take a look at the data set and let's think about the first question we are going to answer here. So maybe I only want to extract the flight information on the upper state New York. So you can see this is a flight information with 32,000 entries. So first of all, I want to create a smaller data set only for upper state New York, which would be, it can be easily done through a function called filter. So what we are going to do here is to just do, first of all, I want to copy this line to the code chunk so that you can see I can just run this line for filter and I can access the data set. So now I'm going to filter this data set to create a smaller data set. So the data set I want to use is based on the origin city name. So you can go back here, or the best way to do it is to run the names function on the data set so that you can get the origin city name correctly typed. And then, because we are talking about upper state New York, right? It can be Albany, Buffalo, Rochester, and Syracuse. So what we are going to make sure we are going to select all the city names that are within this box. So we are going to type out all the names here. If you are not sure of your spelling, it would be a good idea to run in the console. Maybe you can run the table function and you can print out all the origin city names. So let's do Albany, New York, Buffalo, New York. So I just randomly picked a few places. Let's also do Binghamton, New York. And let's randomly pick another one maybe. Okay. Yeah, Syracuse. Okay, so make sure you don't have random open spaces in your filter function. So what I did is filter and use that column name if the column names or the records are within those options, they will be selected out. I'm a little worried about using Binghamton because it only has 30 records. So maybe we can use, maybe let's use this instead of Binghamton. Yeah, so let's run this. There is no error. So what you can do actually afterward is to name this data set as selected New York. I call it selected New York. So you can rerun those lines and you created a new data set called selected New York. One thing I always do is to make sure the selected data set has all the information I originally wanted. So I'm actually selected New York. Okay, I have a typo there. Selected New York, and I want to make sure all the 4 places I selected are there. So as you can see, I only had 2 of the cities. And I noticed that there is a space here and there is an extra space here, which is wrong. So I rerun those lines and I rerun next line to make sure all 4 places were selected. And now the smaller data set is created successfully. So this is a subset of the original data set. Let's take a look at the data about the date. So let's run the selected New York on the column flight date, and let's see what are they looking like. So it's month, day, and the year information, which is nice, right? But if you look into the data set, you can see the flight date is actually recorded as character. They are recorded as character. So what we can do here is to make another change to this data set using a function called mutate. So we can mutate this data set according to that flight date to generate a new date, flight date for it using month, day, year, and then put in the original column name in there. Okay. So in this way, if you print it out, you can see that last column now should be about a time. So let's give this a name. Time with time, right? So give this a name and you can view this newer data set and see what has changed. So the last column is a flight date, and you can see there is a flight date information in there. Okay, the first question I want to solve here is that I want to know the average delay time for each airport. Average delay time for each airport in this data set. So I'm going to do selected New York time, the data set. And then the first thing I'm going to do is to do group by, because I want to know the average delay time for each airport. So it's for different airport. So here I'm grouping by a region city name, origin city name, and then I do summarize because I want to calculate the average delay time. So I call it average delay, and then I name it as the average of, let's see the variable names we have. So it's DEP underline delay. Yeah, so that's the mean value of those. And if you pay attention here, are there missing values or no? I didn't see any missing values. So let's just do the calculation for now and see there are missing values. So let's use NA.remove equals true so that we can remove the missing values and we can calculate the actual departure delay. It's likely that if the departure delay is missing, then the flights are not having a delay. So run this and you can see we generated a nice summary table with average delay time. And you can see Buffalo, New York has the longest average departure delay. And Albany has the shortest average departure delay. Okay. So my next question is, which day of the week has the most flights? So which day of the week has the most flights? So the question here is that we need to figure out the date and then get days of the week information. And then we count how many each day has. So it's a several step process. The first step is that we are going to get the week of the day information, which is muted because we are adding a column to the data set. Day of the week. It would be the function WDAY, and that function should be used on the flight date column we have created. And then after that, so this muted function will add this newer column to the data set based on the date information we have. And then we are going to group by, because we want each days of the week, we count how many flights we have. So it will be grouped by day of the week. And then we are going to count. We are going to summarize, because it's a summary statistic, right? You are counting how many total flights we have. So it's summarize total flights equals, you can just use n and a pair of parentheses. That is for counting the total numbers you have. And you can run this. So this function, the whole process here gives you a data table, shows you each day of the week, how many total flights we have. You can definitely use this one to figure out which day of the week has the most, right? Or you can add another function to print out the most day only. So the function is called slice underline max. And then you check the maximum number of the total flights and you only get the top one. So run those lines, you get the first day of the week, which is Wednesday, has the most flights. One thing you can add on is when you get days of the week, you get label equals true. So let's see if this can help with anything. Run all the lines we have. So you can see it printed out Wednesday. instead of number 4, which is more straightforward and helpful. Okay, so the third thing we are going to do together is to draw a heat map, which I think is very helpful. And the first thing we are going to do is to install a package called GG time series. I'm not sure if this package is also in tidyverse. But when we loaded the package, I'm just checking. Okay, I'm not seeing it here. Okay, load the package using install.packages library of GG time series. Make sure you load the package so you're able to use it. So what we are going to do here is that, remember we had, let's just do it. So we are thinking of draw a map according to the calendar or days of the month. Days of the month on calendar to show the delay time. The average delay per airport or per city. You can think of it that way. So we are thinking about the date, the airport, and also the delay time. So we are going to start with the data set we have created. And then the first process we are going to do is to group by. We are going to group the data by flight date, as well as the departure city name. And then the second thing is to summarize the delay time according to the flight date, as well as the city name. So let's call it average delay equals mean value of departure delay without considering the missing values. And this calculation will give us flight date, city name, and average delay. The next thing we are going to do is to ungroup them because we want to use the data set to draw our graph here. So what we are going to do is to do ggplot calendar heat map. So this one would be like a calendar, but it will show different colors, like lighter and darker for different values. So the things we are going to draw would be flight date as the first parameter. The second parameter is our average delay. So the first value is to prepare the calendar. The second value is to color the calendar. And then we are going to draw it using different cities. So this would be from facet wrap and through each of the cities. Okay. Yeah, you can just copy this name here to make sure you don't have a typo. And you can run these lines now if you want. So let's run these lines and see where we are. Okay, so this is a map showing the average delay, the lighter, the higher delay, right? The darker, the lower delay. So that's a problem because we want to highlight those with more delay time. So we can make a little change, some changes here by doing scale and continuous. So we want to specify what values are darker and what values are lighter. So let low equals green and high equals red, so that we are seeing different changes here. And let's run this. And you can zoom the picture and you can see we have calendars for each. It's not really a calendar, it's more like, yeah, I think it's a calendar. So it's November for each city and which day has the highest delay. Like that Saturday in Buffalo, it has the highest delay. So I would switch this graph a little bit because the months, the days of the week is on the vertical line, not the horizontal line. So let's do cohort flip so that the graph is flipped like a calendar. So zoom the picture again. And now it looks better because it's a calendar. Sunday, Monday, Tuesday, Wednesday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Yeah, so that you can see a few of the days has the most delay. Like this one has the highest delay. And for Albany, this day has the most, and some of the days also has delays. And for Syracuse, this day has the most delay. And so it is very clear to see through this picture that you can identify those days you may want to avoid taking a flight, right? So let's get rid of the picture, and you can still make some more changes there by, what should we do? You can, maybe we can change the name of the picture. And what we can do is we can change it to light and run this. And you can see this picture is now changed a little bit. And you can also change the X lab, the Y lab, and things like that. Okay, that's about it. So this is a very interesting example, and there are so many things you can do on this data set. Like these two questions are just two example questions that might be interesting. And this third one is about a graph. I hope you enjoyed. Thank you.